Okay, so for this video we are going to discuss something new lah. Okay, this part actually they just try to add it in from year 2020 onwards. All right, so it is actually a new syllabus, okay, that included in this year. All right, so we are going to cover the part how to integrate, okay, the integration, integrate the inverse trigo function. All right, but in our syllabus, they only involve one type of inverse trigo function, which is tangent inverse. The answer is tangent inverse. All right. So for your just to recall back in chapter 4 for differentiation, okay, we learn how to actually differentiate the tangent inverse x. Okay, but I didn't tell you that how to prove it, right? If I'm not mistaken, what we do is that we just try to memorize the formula. So if I want to differentiate tangent inverse x, then I'm having x squared plus 1 squared, or x squared plus 1. Okay, so this part for integration actually is very similar, okay, to the differentiation here. But the problem now is last time when we learned that, you will see that we take x, and then I'm having x squared and then plus 1 squared. Usually the answer here that I get is 1 squared for the differentiation, unless you rephrase everything and so on. Okay, so for today, we are going to learn the opposite way. That means if I want to integrate 1 over x squared plus 1, then I'll have tangent inverse x. But most of the time, right, in the question that you provide, it is impossible that this value is always a 1, right? Okay, so we will learn also, if let's say you're having a, they're not a 1, but you're having a, which is 1 over x squared plus a squared. Okay, how is the integration for it? So the integration will be, it is still tangent inverse x, but you need to divide it by a. And then outside, you also need to divide it by the a, the constant. All right, and then plus c. So this is something new. Again, mostly we are trying to memorize it, the result. Okay, so to apply this result, there's one important rules that you need to know also. Okay, when you want to apply this result, generally you have to make sure that the coefficient of the x squared before you want to integrate, it must be a 1. Alright, if not, then you won't get the correct answer. Okay, of course, there are some other ways also, but for me, if let's say I want to make it easier for you to understand or to apply the rules, then I should tell you that this value here, the coefficient should be a 1. Then it will be much more easier for you to apply the rule. Okay, so you have to always remember this, right? Because the formula here actually shows you that in front of x squared, there's nothing else. It must be a 1. They didn't write it as ax squared or whatsoever, right? So they only write it as x squared. So it must be a 1 for you to apply the rules here. Okay, so let's have a look and see how are we going to integrate all this. Okay, so for example 11, part A. Okay, so for part A, you will see that this is the equation that they want you to integrate, and then this is the 1. Okay, so the coefficient itself is already a 1. Therefore, you no need to do any adjustment. Okay, so if you continue from here to do the integration, maybe you want to rephrase it, become x squared plus a squared. So 36 means 6, so it will be 6 squared. Okay, so now if you look at this one, you already have the pattern of x1 over x squared plus a squared, where your a is actually a 6. Okay, so when you want to integrate it, you will get tangent inverse x over a, so x over 6, and then outside is 1 over a, so 1 divided by 6, and then plus c. Okay, so this is how you apply the equation. It is actually quite simple, but you have to memorize it. Alright, and then just make sure that the coefficient of x squared is a 1, before you apply the rules, before you apply the formula. Okay, alright, so let's look for part B. Okay, so for part B, again, this example, if you look at it, it is not starting from the coefficient 1 anymore, right? Therefore, you actually have to do some adjustment. before you can apply the formula for integration. Okay, so since I want to have 1 as the coefficient, therefore I will take out the 4 from x squared, and then this value, it will become 5 over 4. And then dx. Agree or not? Because when you multiply the 4 inside the x squared, you have 4x squared. When you multiply the 4 inside the 5 over 4, then you will get a 5, which is original equation. Okay, then now, the 1 over 4 is constant, therefore I will take it out. Okay, then after that I will focus on the integration for x squared. And then for this part, you have to rephrase it become a. So my a should be square root 5 over 2 and then square. Right, so if you not so sure, then you can double check. Okay, no, square root 5, when you square, you get a 5. 2, when you square, you get a 2. So your a is square root 5 over 2. Okay, so after you rephrase it, then you will see that it is actually the pattern of 1 over x squared plus a squared already. Okay, so how can you do it? You copy the 1 over 4, the constant won't be affected, right? So when you try to integrate this one, you will have 1 over 8. So your a is square root 5 over 2. And then tangent inverse. Alright, and after that you're having x over a also, which is x over square root 5 over 2. Then you have a plus c. Okay, so your equation might look, your answer might look a bit complicated now. Maybe you can try to simplify it. 1 over square root 5 over 2 multiply with 1 over 4, you will get 1 over 2 square root 5. Okay, then for this one, you will have tangent inverse 2x over square root 5 and then plus c. Okay, so if you want, you can stop your answer here. If you don't want, then you can try to further rationalize it. So if you rationalize this one, you will get square root 5 over 10. Okay, then tangent inverse. Then on top here, you will have 2 square root 5x over 5. And then plus c. So either one, you can keep the answer in the original form like this, or you can rationalize it become no subform at the denominator. So in my opinion, right, in exam, they should accept this one because it doesn't look simple. It doesn't look simple, but if I say want it to be safe, of course, you can always rationalize it if you want. Alright, so this problem doesn't exist for those who are using ES calculator because your calculator will surely help you to rephrase it in this form. Alright. Okay, so again, if you look at the step here, when your x squared in front got some other value, but the coefficient is not a 1, then you have to take out the value, factorize out, and then you rephrase it into the pattern of 1 over x squared plus a squared, then you can get an answer. Okay? Alright, so continue to part number C again. Alright, so for part number C, I will rephrase it become 1 over 9x squared plus 1. So the same thing happened. So because the coefficient of x squared is not a 1, right? Therefore, you have to factorize out the 9. So when you factorize out the 9, you will have x squared plus 1 over 9. Okay, and then 1 over 9, I will make it as a constant. I will take it out. Then for this part, I'm writing it as x squared plus a squared. So the a should be 1 over 3. So that 1 over 3 squared, you get back the 1 over 9 here. Okay, so once you rephrase it correctly already, then you start to apply the formula 1 over x squared plus a squared. To get a solution, you have 1 over a, so which is 1 over 1 over 3, and then tangent inverse x over a. So x divided by 1 over 3, and then plus c. Again, try to simplify all the numbers here. You will get 1 over 3, and then tangent inverse 3x, then plus c. Okay, so again, as long as you remember the technique that your coefficient of x squared must be a 1, then you rephrase it into the pattern of 1 over x squared plus a squared. Then to do the integration, it is not hard. because you just try to memorize the formula, right? So 1 over x squared plus a squared, the pattern is always tangent inverse something. Okay, so these are the 3 examples that I can show you. Hopefully you get some idea from here. And then later, maybe when you are free, you can try out some other example. Alright, to make sure that you are quite clear about it. Okay, right. So this is how we do the basic integration. Are they going to ask you this in the exam or not? We don't know, because generally this is the basic example for you to understand how to apply the rules or how to apply the formula. Okay, but somehow this is a new syllabus for this year, so I'm not so sure whether will they include in the exam or not. So we'll see how. Alright. Okay, so for example 12. Okay, so besides doing the simple integration, you also need to know how to do the definite integral. In my opinion, the definite integral will not be very hard. Okay, so we can try. Maybe I will want to try part A and also part C for you. Then you try part B yourself. Okay. All right. So let's have a look for part A. So for part A, you're having 2 over x squared plus 1. The 2 is a constant. I will take it out straight away. And having 1 over x squared plus 1 squared. So your A is a 1. Okay. So when you want to integrate 1 over x squared plus 1 squared, okay, generally you have 1 over 1 because 1 over a, so 1 over 1. Okay, so I won't write it out. Oh, maybe I write it out better. 1 over 1, 1 over a. Then tangent inverse x over a, so x over 1 also. And then you need to substitute the value of 1 and 0. Okay, so this looks very weird. So what I want to do is I will just rewrite it again. I'm having tangent inverse x and then 1 and 0. Alright, so when you put in the 1 here, the answer should give you pi over 4. And then when you put in the 0 here, the answer should give you a 0. Alright, then after that, you try to simplify your answer, then you will get pi over 2 as your answer for this question. Okay, so to get the pi over 2, right, there's a small idea or maybe the small technique that you need to know. Okay, when you want to press the calculator, put calculator in radian mode. Okay, because for all the questions that involve integration, differentiation with trigo, all the values in the calculation should be in the unit of radian. You shouldn't be in the degree. So you cannot tell me that tangent inverse x is 45 degree. So 45 degree multiplied with 2, you get 90 degree, which is wrong. They not allow you to do so. Okay, so you have to put it in the calculator in the radian mode. So same thing happen for all the questions here. Alright, and then for part B, I think I will want you to try out on your own. Okay, so the 4 is a constant, you just take it out and then you try to replace your equation here, try to apply the integration. The answer that we get should be 2 pi over 9. Alright, so this is the answer for part B. You go and have a try on your own. And then now we look at part number C. Okay, so for part number C again, you will see that actually you need to do some simple adjustment, right? Okay, so I will take out the 3 from x squared. So when I take out the 3 from x squared, I'm having x squared plus 2 over 3. Alright, so the 1 over 3 is a constant. I will take it out. Okay, then when I rephrase my equation here, my expression here, I'm having x squared plus square root 2 over square root 3 and then square. So you can see very clearly that this is 1 over x squared plus a squared pattern. Okay, so I do the integration. Alright, so when I want to do the integration, what do I have here? Okay, so you'll see that 1 over x squared plus a squared, the formula should be 1 over a. So it's square root 2 over square root 3. Okay, and after that, what do I have? Okay, 1 over a, and then after that, I'm having tangent inverse x over 8. So x over square root 2 over square root 3. And then you need to substitute the value of square root 2 and negative square root in your equation. Okay, so I know that this question will look very complicated. It is very complicated actually. Alright, so we try to simplify everything slowly first. If I simplify the value here, the constant, I will get square root 3 divided by 3 square root 2. Okay, and this one, if you try to press calculator, okay, so you'll get 1 over square root 6 actually. Okay, so if you don't believe, you can try and see how can you get the 1 over square root 6. Okay, or you can have square root 6 over 6 also can. Okay, alright, so I just want to let you know that then you try to figure out how to get 1 over square root 6 and how to get square root 6 over 6. If let's say you don't have ES calculator, you only have MS calculator, how are you going to find out these two? Alright, I will just keep this part for you. Alright, it involves some knowledge, basic knowledge, and also some very basic idea on rationalization. Okay, so this part I keep it for you. Okay, so after I take out and simplify the constant here, then inside I left tangent inverse. I'm having square root 3x over square root 2. And then I want to substitute square root 2 and also negative square root 2. Okay, so next, this part I will write it as 1 over square root 6 because I feel that this one looks a bit complicated. Got a lot of square root and then got some difficult number like 3 and so on. So I would prefer to become 1 over square root 6. Okay, then for this part, substitute the square root 2 into the equation. First one, you have tangent inverse square root 3. Okay, then minus, when you substitute the negative 2 inside this equation, then you have tangent inverse negative square root 3. Okay, so now here we get the problem. Okay, so what is the answer? And how can you find out the value for tangent inverse square root 3? Okay, then now for 1 over square root 6, of course, this is 1 over root 6. Okay, then what do you have here? So tangent inverse square root 3, if you press calculator, okay, and then please, of course, please keep your calculator in the radian mode, then you'll get 30 degrees, if I'm not mistaken. Wait, let me try again. Tangent inverse and then square root 3. Yeah, you have 60 degrees. Okay, or maybe you can draw a triangle to help you. Okay, so for the triangle, right, I know that 1, 2, this is pi over 6, 30 degrees. So this is square root 3, therefore this is square root 6. Oh, sorry, pi over 6. So from this triangle, you will see that tangent pi over 6, it is equal to square root 3. Okay, and therefore tangent inverse square root 3, you should get pi over. Hey, I did a mistake here. Sorry for that. This one should be pi over 3, not pi over 6. This one should be pi over 3. Okay, so this is also pi over 3. Okay, so when you take tangent inverse square root 3, of course you'll get pi over 3 here. Alright, okay, then equals to, then you put equals to. Okay, then now they want to have tangent inverse negative square root 3. Okay, so for this part, if you press calculator, of course you can straight away get the answer also. Tangent inverse negative square root 3. So the answer is negative 60. So you should have negative pi over 3. Okay, all right. So some students might ask, how I know that it should be a negative pi over 3, but it is not some other thing else. Okay, all right. So again, if you want to know the big idea behind this, then you need to know first, tangent pi over 3 is equal to square root 3, right? Okay, but now they want to find out the negative square root 3. Okay, so for negative square root 3, in what quadrant do you have? Okay, so tangent positive, so this is all positive, then sine positive, okay, then tangent, and then cos. Okay, all right. So for tangent pi over 3 equals to positive, so they accept the first quadrant here. Okay, and then for negative, all right, so for the negative, actually they are measuring from this direction, negative area. So they know that if let's say I'm having negative pi over 3, okay, then your value for tangent in this part will be negative square root 3. Okay, so maybe some students will ask me why they don't measure it in the positive angle and you get the second quadrant here. Okay, so the reason is because for tangent inverse function, there's a fixed range for the tangent inverse. So the range is actually in these two quadrants, and after that, one value is positive and one quadrant is negative angle. So it is fixed actually for the tangent inverse function. But the problem now is we didn't learn all the detail for the tangent inverse. Okay, like what is the domain for the tangent inverse, what is the range for the tangent inverse. All right, so therefore it might be a bit confusing for you, but for now please make sure that you remember for any tangent inverse, the value for positive you should take first quadrant, the value for tangent negative you should take the fourth quadrant, but you show them in negative angle, in the opposite direction, so that means it's a negative angle. Okay, so that's why I'm having negative pi over 3 here, and then when you try to complete and simplify it, you will have 2 pi over 3 and then square root 6. Okay, so this is the exact value. Then for this question, because I didn't mention whether should I find out the exact value or whatsoever, then you can just try to press calculator and get the decimal place number also can. 3 significant figure. Alright. Okay, so this part is a bit hard if let's say you want to find the exact value, but if let's say they didn't request for exact value, then it's quite easy. But for me, I'm more concerned about this. Right, so you always have to remember that for tangent inverse function, okay, the domain that we take is from negative, I should write like this, negative pi over 2, wait, is it the range or the domain? It should be the range. Okay, so the range is tangent inverse, should be from negative pi over 2 until pi over 2. Alright, so this is something that I think is quite important, although we didn't cover here, but I think it's quite important for you to get the solution, okay, for the integration. Alright, okay, so again, I understand that you might need some time to absorb all this, but maybe you just try out a few more examples and see whether you get the idea or not. Okay, alright, so let's continue for the last example about this. Okay, so for example 3, I take it out from a specimen paper, okay, for year 2020, okay, because they want to show one example, like how are they going to ask you the question for this part. Okay, so let's have a look here. First part, they want you to show that the differentiation for this, you'll get equation like that. Alright, so how can we start? So what am I going to do now is I'm trying to do the differentiation for x minus tangent inverse x. Okay, so we learned it before. Differentiate x, you'll get a 1. Minus is a minus, so differentiate tangent inverse x, you'll get 1 over x squared plus 1. Okay, then I try to combine these two terms, become one fraction. You're having x squared plus 1 and minus 1 here. and therefore if you try to simplify it, you'll get x squared over x squared plus 1. Okay, so to me, I think this is quite simple. Okay, it is not hard actually. Can I? Alright, then after that, they want you to show that tan x, tangent inverse x equals to this part. Okay, so for this example, this particular example, we cannot do it from now yet because it involves the integration by part. Okay, so you need to learn a technique for integration in this chapter later, which is the integration by part. Alright, so after you learn the integration by part, then only we can try to integrate this. Okay, so for now, I will skip this part first, and then we'll come back again after we complete the integration by part technique. Okay, so this is what I want to cover for this video. Alright, so later I will let you try out, okay, some questions. I will ask you to try out some tutorial questions so that you manage all the idea and all the steps, okay, for this part of integration. Okay, so I'll stop here for now.